Okay, so picking up with the 2.4 notes that we left off on yesterday, why don't you go ahead and give me a polynomial function in least degree, that means smallest exponent, with the real coefficients, with real coefficients in standard form that has the following zeros. Ready, set, go. Go ahead. So you just took a quiz over this. Should be pretty good with this, knowing, understanding what exactly we need to have here. So if it's write a function, the first thing I should do is write f of x equals, because that's a function, f of x, and then in parentheses x minus each 0. Minus negative turns into a plus. Okay, and remember, no fractions. So if you were given a fraction here, you'd have to multiply that factor by the bottom number, and that way you get a factor with no fractions. So for example, just for the sake of the video here, if I was given the solution x equals 1/2, the factor that would come out of that is 2x minus 1, not x minus 1/2. Okay. But back to this problem. You are foiling all the way into standard form. So those foil together like that. And then a round of like triple distribution, however you organize your work there. X cubed plus 7x squared plus x squared plus 7x minus 6x minus 42. So your final function is x cubed plus 8x squared plus x minus 42. Is that what you guys got? Great. That is in standard form as opposed to factored form. It is a function because it starts with f of x. It is least degree, meaning I didn't add no extra zeros and no extra exponents on my factors to begin with. Cool. Try this one. This one has a little trick in there. It has this root 3. And a root 3, think about the kind of factor that makes a root 3. We've seen some of them before. Here's how they start out. They start out x squared minus 3 equals 0. Don't they? And then you set it equal to 0. It's x squared equals 3. And then you take the square root and you get root 3. But what do you always have to remember when you're going in this direction? It's always a plus or minus. I didn't include that when I listed out the zeros for you, and I'm not going to. You've got to remember that it's there. Okay? It's often not written because it's assumed given the context of the problem. So as soon as you see that root 3, you should think plus minus root 3. Okay? That goes for any irrational or imaginary 0. So you have 4 factors for this one. X plus 1, x minus 2, x minus root 3, and x plus root 3. Now this is an odd question. But would you pair these two together in foiling? No. No. That'd be a terrible idea, Mr. Wagner. Don't do that. Pair together the ones that look alike, because a lot of times they're going to combine together in a nice way. So foil those two together instead, and then foil these first two together. So when I foil X times x, I'm working on the right side because that one's weirder. X squared plus x root 3 minus x root 3. And then root 3 times root 3 is what? Well, it's root 9, which is what? 3. Right? The square root of 9 is 3. And then, like I said, pair those together because look at that. Those two, when you combine like terms, those two got to cancel each other out. Then you have one more little round of distribution to do there. And combine your like terms. X to the fourth minus x to the third minus 5x squared minus 3x plus 6. Tell me if you got something different. Yeah, thanks. I felt like there were too many negatives in a row there. There we go. Awesome. We're all math friends. See? We just help each other out like that. Okay. All right, let's do another one. X equals 2, x equals negative 1, and x equals, that's not 2 and negative I, that's 2 minus I. Okay, read carefully. Remember on the quiz there was a little comma there? So it was like, it wasn't 3.5, it was 3 comma 1/2. So look very closely at some of those little details. This is 2 plus I. The same little hidden detail is in that as was on the last one. This is 2 different zeros. It's a 2 plus or minus I. Okay. And if you remember from like doing quadratic formula or complete the square, you often end up, because what causes an I? A square root of a negative. Okay, so when that square root comes in, it brings the plus minus into it. So you've got 4 factors. Let's write them out. Write a function, f of x, x minus 2, x plus 1, and then x minus 2 minus I, and x minus 2 plus I. It's always x minus, guys. It's always x minus. It's x minus 2 plus I or x minus 2 minus I. And then you're multiplying again. Pair these together as you're multiplying. It's going to work out better. I don't know how you organize your multiplication when you're multiplying polynomials, but if you're bad at it, here's a nice way of organizing it. Make yourself a little 3x3 box. Since it's a trinomial times a trinomial, x minus 2 minus I across the top for that first one, and then along the bottom, x minus 2 plus I along the side. And then multiply into the squares of the box. So x times x is x squared. X times negative 2 is negative 2x. You got negative xi there. Minus 2x here. Plus 4 there. And minus 2i. xi minus 2i. Sorry, this one was plus 2i. And then minus I squared. And what is always supposed to happen, whether you use the box or you just, do arcs and remember all 9 multiplications, the i's, the terms with I should always cancel out on this problem, okay? Hey, just for terminology's sake, remember 2 minus I and 2 plus I, that pair, those are called conjugates. Conjugates. So, did I spell that right? Yeah. Okay. So when we combine our like terms here, the other thing about I, the last I didn't cancel out, but what is I squared? Yeah, I squared is always equal to -1. Always. So you always make that substitution. So really this becomes negative, and then what went in the place of I squared is a -1, which is 1. Okay. So this is x squared minus 4x plus 5 times x squared minus x minus 2. And then you need to multiply those. If you don't like the box, here's another way I do it sometimes. I will use color-coded arches. So negative x to the third, positive 4x squared. And as I'm doing these, I'm lining up like terms. So minus 2x squared plus 8x, and then minus 10. So that when I combine like terms, everything's lined up already. F of x, don't forget it, equals x to the fourth minus 5x to the third plus 7x squared plus 3x minus 10. Is that what y'all got? Hey, this one looks fun. I'll let you go for it. I'll let you go. You know everything you need to know at this point. There you go. There you go. You can do it. I've already done one with a root and an I, so you know how it's going to go. Yeah, it's like a movie you've already seen before, right? It's just as fun.
Movies are fun.
All right. I'm going to freeze the screen, and then I'll put my answer up there in a minute. Okay. So there's the first 2 rounds of multiplying. So you check and make sure you're in the right spot, and also check me to make sure I'm in the right spot. Okay. And then keep going. Finish up if you haven't. Okay, there is my final answer. Yep. Thanks. I know this may come as a surprise to you guys, but I was the kind of math student that completed my quiz and then went and reworked every single problem again and found all these mistakes like that. So, yeah, I would go over every problem twice because I just make so many little mistakes. I mean, you see it. So, I would hold on to the quiz for every minute that I could. All right, any questions on here? All right. Let's keep moving. Oh, sorry. All right, find the zeros first. Write the function as the product of linear factors and irreducible quadratic factor, and the product of its linear factors. Okay, so let's find the zeros. Can you factor this? Anybody? I can't. Maybe you can, I don't know. No, so if we can't factor it, well, that means I was supposed to give you a factor to divide out, right? And then we could get down to something that we could factor, but then I didn't. So what do you have to do? Yeah, you got to use the rational zeros, right? The P and Q thing. You got to come up with your own list and then try them and see which one works. Here we go. All right. Remember QP. Okay. So your P over Q list. Oh, look, this is super easy. It's 2 and a 1 for P and Q. So, okay, you have a list of 4 to choose from. 1 and 2, positive or negative. So you're welcome. And remember, like I said, on a quiz or a test where you have no calculator, either positive or negative 1, positive or negative 2, one of those 4 options are going to work. Okay, I'm not trying to waste your time. So I'll try positive 1. Okay. So 1 times 1 is 1. 8, 8, 12. Doesn't look like it's going to work. So try negative 1 instead. Yeah. So 1 plus nothing is 1 times negative 1 is negative 1. Plus 7 is 6, negative 6. Plus 4 is negative 2 times negative 1 is 2. And you get your 0. Okay. So at this point, let's pull that out and factor it. That's an x squared plus a 6x minus a 2. Why again do we know it works? Because we got the 0 as the remainder, right? That's how we know it's a factor. And what is the factor? Yeah. It's a negative 1 that you sent through synthetic division. So the factor that we proved is x plus 1. Okay. So when you write the function, f of x equals, right? Write the function. It's x plus 1 at the end. Don't forget to write the factor you just proved. Okay. Now, did I talk about the names of these already? I can't remember if I did or not. So the factor that would make a line, if I were to put it into Desmos, that's called the linear factor. So this is the linear factor. It's x to the first power. It's a linear factor. Or just a 3. If I had a 3 out front, that would also be a linear factor. Okay. The factor that if you plugged it into Desmos, it would make a parabola, a quadratic, is called a quadratic factor. And if it can't be factored anymore, which can this one? No. We call it, you ready for this? An irreducible quadratic factor. Okay? So when your instructions say, write the function as the product of the irreducible quadratic factor and the linear factors, this is what they want. They want the irreducible quadratic times the linear. Okay? So that is one part of the problem that's been solved for us. But they also want it as a product of the linear factors. And they wanted us to find the zeros. If we find all the zeros, the real ones and the non-real ones, what are we going to have to do with this quadratic? We're going to have to factor that more to find more zeros. But I just got done saying it can't be factored. Oh my gosh, is factoring the only way to solve a quadratic? Oh man, you can use the quadratic formula. Or complete the square is always an option. Okay. I kind of like complete the square. This is a nice problem for complete the square because it's 1x squared and there's an even b value. So x squared plus 6x, make some space for that perfect square trinomial by moving the 2 to the other side. And how do we find that perfect C value? Remember, it's b over 2 squared. So 6 divided by 2 is 3. Squared is 9, so plus 9. Remember that? And that's always really nice because this thing factors into a perfect square trinomial, x plus 3 and x plus 3. But we want to write it like that. That's the whole purpose of complete the square, because I want to write it like that. Equals 11. Okay. And then take the square root. We're solving for x, remember? So x plus 3 equals plus or minus the square root of 11. So x equals 3, negative 3, sorry. Subtract the 3 over to the other side. Plus or minus root 11. Okay. So what are all of the zeros? Well, there's the one that we proved using synthetic division, negative 1, not positive 1. X plus 1 is the factor. X equals negative 1 is the 0, the solution. So that is our list of zeros right there. That was part of the answer. We already gave them the irreducible quadratic factor times the linear factor. And then the other big thing that they wanted was the function as the product of its linear factors. So here, we are out of space on the bottom, so we'll do that up here. F of x equals x plus 1, x minus negative 3 plus root 11, and x minus negative root 3 minus 11. And then, of course, minus turns into a plus. If you are very rigid in your mathematics, you might wonder, like, it feels like you should put the 3 minus root 11 in parentheses when you do x minus it. I promise you, if you do that and you distribute the minus, it's going to end up being both of these two as your factors. Okay? So that is very good of you. If you're like, I feel like you can't do that, Mr. Wagner. I'm only skipping that because I know it's going to end up being the same thing either way. Oh, yeah. See? See? Plus 3 minus root 11. Okay. Okay. And that is the product of its linear factors, right? Factors that have x to the first power. Okay. You tried this one. So I'm going to tell you right now, like I said, on your quiz and your test, you know the numbers that are going to work in synthetic division when I give you this kind of problem. On your homework, they're not that nice, okay? So on your homework, if you get a problem like this, where your list is gigantic, put the function into a calculator, look at the x-axis, find some whole numbers, okay? All right. Okay, so you should, if you pop it into the graph, you should learn that 6 and 1 should work, right? Okay, so let's do 1, 2, negative 1, negative 73, 36, and 36. So run those two through, 6 and 1, and then see where you get from there. Okay. After you run 1 and 6 through there, this is the quadratic you're left with. So is that your answer to the irreducible quadratic and linear factors one?
No.
Okay. Did you try to factor it?
Yeah.
Go ahead and try to factor it. Don't just assume. Try to factor it. Don't avoid it just because it's 2x squared. Okay, that's what I got for my product of linear factors. Is that what you guys got?
Can you write x squared minus 36?
You cannot write x squared minus 36 because that would not be fully factored form, nor would that be a linear factor. X equals 6, negative 6, 1, and negative 1/2. Right, if you set each of those factors equal to 0. You can write plus or minus 6. I would prefer that if you do that, though, that you put it at the end of your list so that I don't think that the whole list is plus minus, right? So, or just separate them out like that to play it safe. Cool. So there are no irreducible quadratic factors, so we don't have to do that part. All right. Let's skip to this very last, number 14. Number 14 here. So we have this big quartic function. It's with the x to the 4th power, quartic function. And we have a given 0 there. How many zeros have you been given? How many? 2. 2, right? Did you catch that? Because it's always plus or minus. This is 2 plus or minus 3i. 2 plus minus 3i. You have two options for this problem. First, the first option, this is x equals. You could, their factors are x minus 2 plus 3i and x minus 2 minus 3i. Those are the two factors. You could multiply them together, okay, and get a quadratic that's irreducible, and then you would have to divide it out of this polynomial function to get down to something small enough to factor by hand, okay? So that's plan A. Give me a thumbs up if you understand plan A. Okay. Multiply these two known factors together and then divide that from our function. Plan B, if you're up for it, you could do synthetic division with each one of these these zeros. Did you know you could do synthetic division with a complex imaginary number? What? I know, your minds were just blown. It's possible, okay? You could try either way. You just need to observe the rules of synthetic division, all right? The only rules were the corner number needs to be the solution. So one round will be 2 plus 3i in the corner. The second round will be 2 minus 3i in the corner. You should get what as a remainder? 0 for both rounds. And it's always add down, multiply back up. Okay? I'll let you decide which way you want to go. Okay? Remember, if you take the plan A, you have to do long division. Because what you're going to get when you multiply those two is a quadratic. So you decide what route you want to take and then go for it. If you're doing synthetic division, you're going to want to leave some space, just so you know. So if you're doing synthetic division, here we go. Bring down the 1. 1 times anything is itself. And then negative 6 plus that, just combine the like terms. 6 and 2, that's the negative 4 plus 3i. And then you have to multiply. So you have to multiply a 2 plus 3i times a negative 4 plus 3i. Okay, here we go. 2 plus 3i, negative 4 plus 3i. That's a negative 8 minus 12i plus 6i plus 9i squared, which is a negative 8 minus 6i minus 9, or negative 17 minus 6i. Then you got to add down again. So that's a 3 minus 6i. That's what you get there. In another round of foiling. You got to keep going. So if you're doing synthetic division It is possible. You're going to have to FOIL quite a bit. The second round of synthetic division will be better than the first. Okay, because the second round of synthetic division, you'll end up having all of these i's that are popping up in this row are going to be canceled out by what you're getting down here. So the second row of synthetic division goes way better, but the first row is pretty rough. Okay, so I'm a little further in. And this is looking good. 2 plus 3i times 2 minus 3i. Anytime I multiply conjugates, it's good news. 4 minus 6i plus 6i minus 9i squared, which is, well, that's just plus 9 there. Those cancel out. So that's 13. Boom. And I get my 0 that I was supposed to get. So it works. And here we'll do 2 minus 3i. One times anything is itself. 2 minus 3i. And look at this second round here. We got a negative 4 plus 3i plus a 2 minus 3i. Well, those are just going to cancel. And I get minus 2. 2 times 2 minus 3i. Well, that's a negative 4 plus 6i. And oh my gosh, look at that. The 6i's get to cancel. That's amazing. Negative 1. And then negative 1 times that, that's a negative 2, plus a 3i, and lo and behold, you get the 0. So you prove that those two are true. And you get x squared minus 2x minus 1. Oh, so I have to keep factoring or solving. Can you factor that? Nope. Complete the square, y'all. It's so easy. Look at that. 2 divided by 2 is 1. Squared is 1. So it becomes x minus 1 squared equals 2. X minus 1 square root equals plus minus square root 2. X equals 1 plus or minus the root of 2. Those are your other two zeros. Find the remaining zeros of the function. There they are. All right. So for our last example, I'll do long division, just to give us some variety here. So we have our factors, x minus 1 minus root 6, x minus 1 plus root 6. So if we FOIL those together, x squared minus x plus x root 6 plus 1 plus, minus minus x, and then minus root 6, and then minus x root 6 plus root 6 minus root 36, which is 6. And then we add those together. All of the roots cancel out. So we get x squared minus 2x minus 5, the 1 and the negative 6 minus 5. And we're going to do long division with that into this polynomial, x squared minus 2x minus 5 being divided into x to the 4th minus 8x squared plus 26x squared minus 8x minus 95. So we should expect to get a remainder of 0 here because 2 zeros are hidden in here. Both of them are represented by this, so we should still expect the same 0. So x squared into x to the 4th, that's x squared. We get x to the 4th minus, I made a typo here, that's to the 3rd, minus 2x to the 3rd minus 5x squared, and then subtract all 3 columns. Negative 8 minus negative 2 is negative 6. 26 minus negative 5 is 31. And then bring down the 8x. Okay, so I'll finish out this process and then you can see where I'm at. All right, so I finished up my long division, and you see that if you're subtracting all the columns correctly and minding your signs, you'd still get the 0 in the end. And so my factored form is the original quadratic that I know, and the one that I just found, x squared minus 6x plus 19. Okay, now they said find the remaining zeros, so I already know the zeros that that one creates. I'll go ahead and finish solving this one. So x squared minus 6x plus 19 equals 0. And I already did complete the square twice. I like it, but I'll show the quadratic formula just to mix up the variety here. So we've got negative b, remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. And that's x equals. So x equals negative b. There's my negative for the formula, and then that negative came from the quadratic, plus or minus the square root of b squared minus 4 times a times c over 2a. So x equals 6 plus or minus the square root of 36 minus 4 times 19. Let's see here. That's 76 over 2. And if we keep simplifying that, that's 6 plus or minus the square root of 40. And of course, the square root of 40 is 2 root 10 over 2, which reduces to, if you want to reduce that, all of these have to reduce together. So each gets divided by 2, 3, 1, and 1. So that's 3 plus or minus the square root of 10. And you can see maybe why I prefer complete the square if I can. So, all right.